Hello, welcome to another geometry lecture. This one is Geometry 7.3, titled today Similar Triangles. First, looking at the angle-angle similarity postulate, it states if two angles of one triangle are congruent to two angles of another triangle, then the two triangles are similar. A picture representation of that: if angle J in the bottom triangle is congruent to angle X and angle K of that left triangle is congruent to angle Y of the right triangle, then triangles JKL is similar to triangle XYZ. So the difference between congruency and similarity is similarity, you only need two of the three angles to be congruent to each other, to be similar. Restating the postulate on the top, another picture, the angle-angle similarity postulate. Down the bottom, it talks about all of the properties that hold true for similarity. The reflexive property holds true, the symmetric property holds true, and the transitive property. So just like congruency, the similarity properties hold under the laws of reflexive, symmetric, and transitive. Not only can we prove triangles similar by angle-angle, having two of the angles being congruent, we can also prove triangles similar by side-side-side. If the corresponding side lengths of two triangles are proportional, then the triangles are similar. And they give the example of JK over MP equal to KL over PQ, and then equal to LJ over QM. If all of that's true, then the two triangles are similar. Same situation on the bottom. Side angle side similarity states that if the lengths of two sides of one triangle are proportional to the lengths of two corresponding sides, of another triangle, and the included angles are congruent, then the triangles are similar. So we will apply the similarity postulates for angle-angle, side-side-side, and side-angle-side. Question says, determine whether the triangles are similar. If so, write a similarity statement. Explain your reasonings. So we have the two triangles ABC and DEF, and it states since B is congruent to D, since the measures are equal, they're congruent to each other. And by the triangle sum theorem, 42 plus 58 plus A is equal to 180. That means that angle A is also 80, which means then that if A is 80 and E is 80, then A is congruent to E. With that statement, then, the two triangles are similar by the angle-angle similarity postulate. If we know that we have angle A being 80 degrees, we have two congruent angles there, we have two congruent angles there, and then by angle-angle similarity postulate, we have the two triangles being similar. Good. Next example, determine whether the triangles are similar. If so, write a similarity statement, explain your reasoning. So we have parallel lines. We know from before, doing proofs, that we have vertical angles as well as alternate interior angles being congruent. So we have angle QXP congruent to angle NXM by the vertical angles theorem. Since we have the two parallel lines, Q and N are congruent, that'd be that alternate interior angles theorem. So therefore, then, triangle QXP is similar to NXM by the angle-angle similarity postulate. Not too bad. Continuing on. Determine whether the triangles are similar. If so, write a similarity statement, explain your reasoning. So I have two triangles again, ABC and CDE. They share an angle in the middle, and I do not have any of their measurements given to me. So I could say that angle C is congruent to angle C, but then I'd have to look at the sides. So I'm going to have to use a second similarity statement, perhaps side angle side similarity, or I will disprove that they're not similar. If I put all the ratios of the sides together, AB and DE, so let's just highlight that, AB over DE, that's 9 over 6 or 3 over 2, AC over CD, 6 over 4, also 3 over 2, and then lastly BC over CE, 7.5 over 5, which is also 3 over 2. Since all of those sides are proportional to each other, we have either the side-side-side similarity theorem, or also, in my opinion, because we know that angle ACB and angle DCE are congruent, it could also have been by the side-angle-side similarity theorem. So therefore, the two triangles are similar. The key, though, is that the ratios are all equal to 3/2. Next one. Determining whether we have similar triangles. The two triangles that we're looking at would be triangle MNP and MRS. So we know that angle M is congruent to itself by the reflexive property for triangle MNP and then MRS. And I have to take a look at the ratios of the sides. Taking a look at the, I have the reflexive property, I stated that already. Taking a look at the ratios here. MP, which is one side 12, MP over MS, that's 12 over 30, which is 2/5. MN over MR, which is 10 over 25, which is also 2/5. Using that statement and the fact that I have a congruency of angles M and M, I can state that the two triangles are similar by the side-angle-side similarity statement. And my similarity statement would be that triangle MNP is similar to triangle MRS. So again, that was side-side-side we've used, side-angle-side similarity statement, and angle-angle-angle similarity statement. Alright, different type of problem. It says, given that the two triangles, we know already now that the two triangles are similar, BTW is similar to ETC. First part A says write the proportionality statement. B says then find the measure of TEC, and then lastly find the lengths of ET and BE. So the proportionality statement will have all of the sides being congruent. So there we are with A. Side length ET over side length BT is equal to TC over TW, and lastly CE over BW is also equal there. So there's our proportionality statement. Question B says find the measure of TEC. If I take a look here, I have the measure of TEC. If I know triangle BTW, I'll put that in green here, BTW is similar to triangle ETC, then I know that angles E and angle B have to be congruent to each other. So I have here angle B and actually be angle TEC. Those have to be congruent to each other because they're similar. So therefore, since angle B is congruent to angle TEC, the measure then has to be the same, and the measure of TEC then is 79. Alright, lastly, it says find the length of ET and BE. Well, I do have some side lengths given to me, so therefore I can use my proportionality statement from A and plug in the values. So I have ET over BT is equal to CE over BW. Plugging in the values, I have ET as my value to solve for. I have BT as 20, CE is 3, and BW is 12. Cross multiply. ET times 12, 3 times 20, 60 is equal to 20, or sorry, excuse me, 60 is equal to 12 ET. Divide 12 on both sides, and you have ET is equal to 5. So that's solving for ET. Let's solve for BE next. We have BT, which is equal to BE plus ET. And if I know that the entire length is 20 and ET is equal to 5, which is the top here, I can just do simple subtraction and I'll end up with BE being 15. Good. Similar type problem. Next one here. Write a proportionality statement, find the measures of M and P, and then find the length of MN and QM. Proportionality statement, the triangles, PQ over LM is equal to QN over MN, and NP over NL. Find the measures of M and P. If I know that I have 106 at N, I know I have 106 on N and the other triangle. If I look at my my similarity statement, I have M and Q being in the same spot, and N and obviously being in the same spot, and L and P. So therefore I have congruent angles, and I can use congruency statements to help out there. It says measure of angle M is 36, which means that the measure of angle M is 36 and the measure of angle P is 38. That was just by simply solving the bottom triangle here using triangle sum, 38, and then obviously denoting that that M and Q are congruent as well. Lastly, the lengths, you can plug those in. I have NQ over MN is equal to QP over LM. Replace my information that I know. 20 over MN is equal to 30 over 33. 30 times MN is equal to 660. Divide by 30 on both sides, and MN is equal to 22. If MN is 22 and QN is 20, and I'm looking for QM, which is the addition of the two, I can just put them together and end up with QM equaling 42. Alright, next example. It says find QS given the triangles are similar. Find the scale factor. So two things we gotta look at. If we take a look at our triangle, we know that they are similar and we have ratios. We also can tell by the picture that we have perpendicular bisectors here. If RS is 8 and ST is 8 and MS 12 and MP is 12, then we have perpendicular bisectors cut each of those segments in half. If we have a ratio of 12 to 6 from one side to the other, we should be able to use that scale factor to find then QS is what I'm looking for. So taking my scale factor 24 NP over RT, which is 24 to 16, that's a 3:2 ratio. That's my scale factor then. And if I take my ratio of 3 over 2, that means that I have 3 over 2 to 6 over QS, and then I'm left with cross multiplying. 3QS is equal to 12. Divide by 3 on both sides, and QS is equal to 4. So I found the scale factor for the top triangle, then use that because if the top triangle is in to the bottom triangle is in a 3:2 ratio or scale factor, then we know that the centerpieces are also in a 3:2 scale factor because of the fact that they are similar. Good. Next example, similar type problem, different shape. Find QM this time using the scale. Find the scale factor. If I have my small triangle listed as 5 for the base and the entire large triangle as 12.5 for a base, simplify that ratio RT over RP, 5 over 12.5, simplifies to 2/5. That means then that CS and QM have to also be in a 2 to 5 scale factoring. So therefore my ratio would be my 2/5 has to be the same for 6 over QM. Cross multiply. 30 is equal to 2QM divided by 2 on both sides, and QM is equal to 15. So I'm setting up a lot of proportions based off of scale factors, ratios, different things that interact with similar triangles. Alright. Next question. Given that RS is parallel to UT, RS being 4, RQ being x plus 3, QT being 2x plus 10, UT being 10, find RQ and QT. So because we have parallel lines, we know that we will have similar triangles. So basically that top part was just kind of letting us know we have vertical angles, we have congruent angles here by alternate interior angles, so we do have definitely two similar triangles. We're trying to find RQ and QT, so we'll set up proportions then to work with the information we have to solve. We know that RS over TU, which is the base sides, those two triangles on the outside, is equal to RQ over TQ. It's a proportion that we know to be true, seeing as how the triangles are similar. Putting information that we know, that leads us to state that 4 over 10 is equal to x plus 3 over 2x plus 10. Now, there is no difference to solve here as we've done before in a previous section. Using algebraic expressions to solve just means we have to distribute both of the numbers. So we'll have 10 times x plus 3 quantity, and then also in the bottom 4 times quantity 2x plus 10. After cross multiplying, we end up with 8x plus 40 is equal to 10x plus 30. Subtract 10x, subtract 40 on both sides. We'll end up with 2x equals 10. If we do it the reverse way, subtract 30 and subtract 8x either way. Lastly, we're left with x equal to 5. If x is equal to 5, then I can just replace x into my two expressions for qt and for rq. If rq is x plus 3, we have rq being 8. If qt is 2x plus 10, we're left with 20. Again, final answer, rq is equal to 8, qt is equal to 20. Alright, given the lines parallel A, B, and D, E, and the information listed above, find AC. Again, it comes down to finding the proportion. So if we know that the two triangles are similar, and they are, I can write a proportion that's DE over BA and AC over CE. So I'll start with the small triangle. I have 11 over 38.5 is equal to x plus 2 over 3x plus 8, and I can cross multiply and solve. Okay, I will have 38.5x plus 77 is equal to 33x plus 88. Subtract 33x on both sides, left with 5.5x is equal to 11. Divide 5.5 on both sides, and x is equal to 2. That's the value for x, though I'm looking for AC. And if AC is 3x plus 8, I can plug back in. I'll have 3 times 2, which is 6, plus 8, which is 14, which is with our answer of D, 14. Alright, next example, indirect measurement. This is a story problem, skyscrapers. Josh wanted to measure the height of the Sears Towers in Chicago. He used a 12-foot light pole and measured its shadow at 1 p.m. The length of the shadow was 2 feet. Then he measured the length of the Sears Tower shadow, and it was 242 feet at the same time. What is the height of the Sears Tower? So we have this kind of triangle set up here. We know that the pole was 12 feet and that the shadow was 2 feet. We do know that the shadow of the Sears Tower was 242 feet, and we do not, however, know the height of the Sears Tower. But if we take a look at those two triangles there, we do have similar triangles, being down here in the corner, that angle being congruent, and we do have a right angle here and a right angle here. So therefore, we do have similar triangles, which means we can put a proportion together. So putting our proportion together, we know that the height of the Sears Tower over the length of the Sears Tower shadow is equal to the height of the light pole over the light pole shadow. So filling in the data that we gathered there, or was given to us, excuse me, we know that x over 242 is equal to 12 over 2. Cross multiply. We have then 2x is equal to 2,904. Divide by 2, and we're left with a height of the Sears Tower of 1,452 feet. Again, setting the proportion up and solving. Alright, last question. Lighthouses. On her trip along the East Coast, Jenny stops to look at the tallest lighthouse in the U.S. located at Cape Hatteras, North Carolina. At the particular time of day, Jenny measures her shadow to be 1 foot 6 inches in length, and the length of the shadow of the lighthouse to be 53 feet 6 inches. Jenny knows that her height is 5 feet 6 inches. What is the height of Cape Hatteras lighthouse to the nearest foot? So a similar type problem as we just talked about. We have similar triangles. We have the height versus the unknown height of the lighthouse. We have Jenny's shadow versus the shadow of the lighthouse. Our proportion then should come the same way as the previous problem. The biggest thing here is I would make sure that we have either some type of common measurement or not some type. We need a common measurement to do the proportion. So if we're going to do the height of the, or the length of the shadows, we know that J's shadow is 1.5 feet. and the shadow of the tower was 53.5 feet. And it's nice to convert 6 inches into 0.5 of a foot because it's half. And then we know that Jenny's height itself was 5.5 feet. And we do not know X feet for the lighthouse. We can cross multiply here. And we have 1.5x is equal to 53.5 feet times 5.5. So I have 53.5 times 5.5. Do not have a calculator, so I'll have to do this by longhand. I have 25 carried it to 15, 17, 25, 26, 0, and then repeat. Should be 294.25 then. 294.25, and we divide that by 1.5. We should be left with our final result, which is a 196 feet. And again, same proportions as previous problem. Okay, that ends lecture for today. We will take a look at problems from page 479, numbers 1 through 4, 6 to 14, 16 to 24. Thank you. Have a good day.